Hi everyone. In this video, I will be going over how to do some really important statistical calculations. This is from 5.1. It's mostly, I would categorize it as probability. Um, it's going to be a concept that you guys are somewhat familiar with, whether you're aware of these concepts or not. You've certainly done probability calculations. So let's jump right in. Um, I will say we've done a certain amount of this doing relative frequency that's going to correlate. So I don't think you'll struggle too much with this section, I hope. Um, it leaves out a lot of topics that are usually covered in probability with cards, dice, other things. So we might see that later in this chapter, but this is going to ease us into probability. So here we go. The first question is really just definitions. So I don't really like in my videos to go through them because I don't think it's too hard for you guys to learn these. Don't just guess on them, make sure you know them. Um, but yeah, sorry, I get all these messages throughout the day. So anyways, um, that's that one. Here we go. So sort of an important thing with probability. One of the things, if you watch the video on correlation, it's like that where with R in correlation, the number has to be between -1 and 1, or if you take the absolute value between 0 and 1. The same thing's true with probability. Your probability of something has to be greater than or equal to 0 and less than or equal to 1. So that means you can't have a negative probability. You can't have a probability that's bigger than 1. So all this question is asking really is also they have to add up to 1. So that's what this is asking. If you add them up, do you get 1? So if they sum to 1, it's good. If not, it's not a probability. Okay. So, okay, going on to the next. So which of the following numbers could be? Well, really, we're looking at what couldn't be. 0.02 is fine. It's between 0 and 1. This one can't be. 1 is fine. This one's not good. It's bigger than 1. This is good. This is good. Okay. So you're really looking for numbers that are less than 0 or bigger than 1. If you get those, it's not a probability. So we're already on, I know this one has a lot, but we're already on question 5, so it's not too bad. Suppose you toss a coin 100 times and you get 53 heads and 47 tails. Based on these results, what is the estimated probability of the next flip being a head? Well, you guys should all be pretty easy with this. 53 out of 100, right? That's that. Now, in general, the theoretical probability would be 50% every single time. But they're saying if you followed this, right, what would it be? Okay. We have a spinner. What a spinner is it's sort of like this kid's game if you've ever played what's that game? Where you spin it and you have to like put your foot or hand somewhere. I forget the name of the game. But whatever. Um I should actually Google that so you guys are know what I'm talking about. Game where you spin. Such an old game. That game is Twister. So that's sort of what this looks like. You have sort of this dial in the middle, looks like a clock, and you have different colors. Okay. So that's what they're talking about, something like that. And you have an outcome of 1, 2, 3, 4, 5, 6. Um, and checks its color and then spins a 6-space spinner. Type the outcomes in the form B1, 1B. BR. Oh, this is a weird question. So a person draws a playing card. There we go. That's what I was missing. So they're drawing a playing card. So there's a deck of 52 cards, let's say, right? And they're either black or red. And then you have the spinner here. So that's what they're talking about. And then what are all the possibilities? So You can either get a black or red. And over here, you can either get a 1, 2, 3, 4, 5, or 6. So which would be the outcome of drawing a black card and spinning a 1? Well, that's this, right? So to do this, we need to know the total possible outcomes. And if you wrote them all out, which we could do, it's kind of what it's asking. You could get black 1, black 2, black 3, black 6. So there's 6 outcomes for black. Red 1, red 2, red 3, red 6. 6 outcomes for that. So of these, how many are black 1? 1. 1 out of 12. But that would be in a different question. So it's just asking you to write all of these. But probability part of it is saying, what's the probability of getting black 1? 7. According to a certain country's Department of Ed, 41.1% of 3-year-olds are enrolled in daycare. What is the probability that a randomly selected 3-year-old is enrolled in daycare? What they're saying here is probability and percents are basically the same thing. So if 41.1% are enrolled, then we'd expect that to be the probability. So the only difference is we'd enter that as 0.411. Okay. So that's that. Here we go. So going back to the last question, now we have our sample space, and sample space just means all possible outcomes. In this sample space, you could get 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. So what's the probability of getting an odd number less than 9? Now the key word here is less, not less than equals. So we don't include 9. Okay, so we don't include 10 because it's even. We don't include 9 because it has to be less than 9. So we only want the odd ones less than 9. So that's 7, 5, 3, and 1. And that's 4 out of 10. Okay. So you have to convert that to a decimal. Okay. Moving on. We're not really in the real part of this yet, but this is all probability. Um, if if out of 1,000 home runs, 85 are caught by fans, what's the probability? Simply do this. 85 divided by 1,000. And I think the rest you guys can do on that one because there are ones that I want to spend more time on in this video. So let's skip to those 10. 10. Interesting question. I actually met someone in an Uber the other day that's a stats scientist. We were talking little, and his research is in gene expression. Okay, so this stuff is very real. So if you guys get inspired by this course and you want to go into stats, it's highly used field. So this is saying genes are represented with dominant first. Therefore, there are 2 instances the offspring could have genotype SS. List the 2 other possible genotypes. So this is really biology. I believe it's called Punnett square. And so you could have S, let's see, big S. Let's see, how do we do this again? I haven't done this in so long, but S with it's this. Big S, little s. There we go. So when you have 2 big S's, that's that. Big S, little s. And here we get big S, little s, and little s, little s. So they want to write the 2 other ones. That's big S, S, and little s, little s. Okay. And then they're going to ask you probabilities of each, and I think that's pretty straightforward. Here we go. This is more what I want to get you guys able to do. So we have data. This one's going to be a pain, just a heads up. I had to really figure out how to do this, and I had to go back to how we did relative frequency using Statcrunch. So at this point, right, we have to use Statcrunch. There's just the numbers are a little bit too big. We could do it by hand. We wanted to do this by hand. We'd add up the numbers, get the sum, and then for each one calculate the relative frequency. And the relative frequency in this case is going to be the same as the probability. So what we're really doing is we're going to calculate probability by using relative frequency. So we open the data. We're going to go to graph. Don't ask why it's graph. It's just the only way Statcrunch lets you do this. And then we do bar plot. And then with summary, our categories will be type of larceny, theft. Larceny means stealing. I think that's what it means. And number of offenses are counts. And we're going to change this to say relative frequency and make sure you click value above bar. Now notice it doesn't show us. So what you have to do is expand this, and then you can see the relative frequencies, and these are going to be your probabilities. Just turns out that it works out the same, okay? So pay attention to this technique because we can use it for a couple other problems in this homework. And you're seeing that the concept that we used earlier ties into this as well. All right. What the heck? Someone just invited me to a bracket. I don't know why. It's weird. Okay. So that's that question. Question 12. More fun, right? So we have to basically do relative frequency. So let's try this. Let's open this in Statcrunch. And does it want frequency or relative? So probability, guys, when you see that, think of that as relative frequency when we're working with data. So what we want to really do is stat tables frequency, and we want the relative frequency to be calculated. Boom, click variable 1. And so you can see right here, my relative frequency, 0.5, 0.067, 0.433, those are my probabilities. So relative frequency is probability, okay? So that should help with question 12 using Statcrunch. Here we go. Let's do a similar question. Yeah, don't laugh at this. You'll see this, there's a lot of data in this one, so I just tried to guess and was wrong. So for this one, it's a bit confusing and the data is a little overwhelming. I'll open it here. This is just about crossing railroad tracks for 200 days, and the person wrote down each day whether or not a train passed them at that time. So it's a very unique problem. I probably would not test you on this. So what's happening here is each time in this column, train, each time the person saw a train, they put a 1. When they didn't see a train, they put a 0. In the column for aggregate train, what they're doing is every time a new train was seen, they add 1 to the aggregate. So it's like aggregate's like cumulative frequency. So every time they see a train, it gets added. So at the very end of the 200 days, the person had seen 40 trains. The fourth column is the tricky one. In aggregate proportion, each time they see a train in the aggregate total, they divide it by the day, right? So for here, right here, they've seen 0 trains, so it's 0. At this point, day 6, they've seen 1 train total, so this number is 1 divided by 6. On day 7, they don't see a train, so they still have only 1 total out of 7 days. So the proportion goes down and so on. Okay. What's happening though is the proportion, which is like relative frequency, corresponds to probability. So each day it's sort of changing the probability, and by the very end, we have our expected probability of seeing a train. Okay. So this one's not too bad. For the first 10 days, how many trains did they see? Well, let's go down here. They've seen 2 total out of 10. So that's 20% or 0.2, right? So we use the last column for each one. So it's already kind of done for us. You go to part B, 20 days. Oh no, I closed the data. So sorry guys, I gotta go back and open this. My bad. But it's hard when you have all these windows open. So for day 20, we say, what's the proportion at that point? It's 0.25. Okay. 0.25. For day 30, were you stopped on it by a train on that day? Day 30, did they see a train? No. Okay. Your data might be different, so make sure all 200 days, what proportion. So then we just go down and we look in column 4 for day 200, and you can see it's 0.2. Okay. Anyways, that's that. And again, guys, I hope these videos help. This one's a funky problem, but it's just saying which of these different, I guess, weights of tails heads would go with all tails, and it's clearly this B, but it's a weird question. This is asking us to write out sample space. We have 3 people, and I guess in this case order matters. Let's see, does it? They're just sending 2 people. Um, so how many ways could we send Clarice, Dominique, Marco? That would be CD, CM, DM. Okay. And then this is our sample space. So in part B, if it's asking what's the probability that CM is 1 out of 3, so that's 1 out of 3. Marco, how many times does Marco go? He goes in these 2, so that's 2 out of 3. And probably that Denise stays home. That's this one. CM is where Denise stays home. Okay. It's a weird problem, but this is just definitions for the first part. So I'm going to kind of skip that because I don't really test you guys on definitions. It's not the most important thing. And you'll know the definitions that are important because I'll use them over and over. Like when I talked about correlation, in this case, this is about probability. Okay. Um, for this one, let me show you how to do this question. You can open up the data and just do a bar graph and or bar you can do a bar plot with summary. Our categories are value of diameter frequency, and make sure you have it put the value of the relative frequency. So let's change this to relative. So that's probability. And this is a weird problem because the actual probabilities that are computed aren't the same, but they're close enough so that we consider them the same. So these would be this would be fair. So it's not loaded. Crazy data one, but we've done this one before. So let me just show you how I got the first part. So for part A, I open up the data. It's massive, guys. It's overwhelmingly massive data. Um, right. It's asking about the important part in this question. This is sort of a unique, important skill set to have when working with data is that, especially when it's massive, you just have to be able to filter out what's important. The important part here is they're asking what day of the week. Okay, so that means we're going to do stat, tables, frequency. And all we're interested in is day, not date, day. What day of the week? Okay, and make sure it selects relative frequency, compute, and this is how I got my answers right here. Okay, so I did stat, table, relative frequency, and boom. The rest are the same. You just have to figure out which column you're doing relative frequency for, because remember, relative frequency is probability for these questions. This one's funky, but it's the same thing. You're going to open up the data. They want us to use data set 2 right here. That's the important part. So that you have to do a little reading, but once you see that, we're going to use this. And then we're going to do relative frequency. So that's stat, tables, frequency, make sure relatives selected, and we want to do birth country. Compute. Um, and you can see the relative frequency, which is probability right there. Okay. So if it asks us what's the probability, uh, non-Hispanic, how come that's not showing? Okay, there's an issue. Hold on. Let's see. Non-Hispanic. Let's try grouping this. So let's group it by race. Still not right. Certainly can't do this by hand. Let's see. I might have to come back to this one or just remove it because it shouldn't. What's happening is, guys, is it's reading non-Hispanic, Asian, black, and white as the same thing. Um, birth country. What's the probability? Does it too? Okay, maybe it's this. So maybe I did this wrong. Let's try this. So instead of using the birth country, let's do column race, and we're not going to group it. Let's see if that does the trick. There we go. All right, sorry. You normally you do the counts as your column, but this one's weird. So there we go. Relative frequency is going to be our probabilities. So all we want to do is enter what we get for relative frequency in the probability um, boxes. Okay. So all I did was I did stat table and then I selected the column as race, not birth country. Give me the probabilities right there. Let's see. Okay, this is the same thing, guys. So just know, like, the difference is in the one we just did, it didn't already calculate the summary. It didn't already add these up, like frequency, like it did here. Well, we already have this done for us. Unfortunately, it's weird. You'd think, oh, it's nice the work's been done, but it actually makes our job harder using Statcrunch. So the only way to calculate relative frequency is to open it in Statcrunch and do graph, and then bar plot with summary. Make sure you select the value of bar and then change the type to relative frequency. Categories is, I guess this is response counts and frequency. And then you'll get these numbers up here are what you want to enter here. Okay. So that's it. That was a long video, but I do hope it helped. And yep, good luck.